big thanks to Jürgen for putting the time. Thanks for wanting at least to share the knowledge and your findings with us. Please, I will let you now share the screen and big applause.
So, okay, warm welcome from Austria. So I'm happy to be here in this awesome community finally. My name is Jürgen. I'm a spatial data engineer with over 20 years of experience. So I'm also the data team lead of our company, ms.GIS. And lead means basically that there are others who can code much better than I, and therefore Daniel is doing most of the commits in our GitHub repository. So you hardly will see any commit from me, but he's doing the hard work. Our company is called ms.GIS for Geographical Information Systems, but we don't only do GIS. We are not a startup. Our company is rather a software engineering company building tailor-made enterprise geographic information systems and solutions. We develop enterprise solutions for customers like the city of Vienna, the Austrian power grid provider, or even the city of San Francisco. So if you live around San Francisco, there's a small bit of ms.GIS software in your everyday life, actually. Yeah, and this know-how we gathered in this field also worked out quite well in other fields of computer science. So it came that we were able to produce a smart home as a service platform for 2 major brands in Europe and South America, providing about 500,000 customers with a fully integrated smart home solution. Yeah. And finally, in the last years, we just combined our fields of knowledge and created a smart city solution, the Spatial Connector. So basically, it's our product to bridging the gap between GIS and IoT for smart cities, as they save a lot of investment in the GIS. Every small city has a GIS actually, and they also want to invest into sensor applications, and to bridge that gap, smart city is our third business. If you are currently around North Carolina, in the city of Raleigh, there's actually the Smart City Connect conference right now, these days. And if you swing by, you could actually speak to our founder, Markus Scheiber, who is talking there and holding a keynote. But that's another story. Let's get back to GIS. So typical GIS information product is a map. Yeah, so if I show you the example of the base map at AT, you have auto imagery, you have airborne laser scanning, you get height models out of it, elevation models, you have infrastructure provided by infrastructure, yeah, streets and railways, and also addresses from the central address register or waterways. And you create a map out of all these different data sources from different providers. That's our major concern, that we have a lot of data from different providers, and to create a good data product with a high standard of quality, we rely on data lineage and good data management. As I said, we also want to incorporate IoT sensors like traffic, railway schedules, water level measures, or any other thing until your private energy management in your neighborhood. So all this data comes from different sources and in a lot of different formats or APIs or whatever. So most data management solutions are about here in the happy land with where the dolphins are swimming, and the products you all know and love, like Hive or Snowflake, yeah. But our business is happening down here, and our data lifecycle management wilderness is happening around all these standards and special formats, and a lot of things we have to integrate regularly on a daily basis. So I like to say that I'm doing this since 20 years, so we had all these big data aspects long before big data was even there. In the topic of metadata, my personal metadata journey started 2001 when my career started. And back then I already was collecting FGDC standardized metadata for all our data sources. And we soon developed a catalog system to just search and provide discovery for this data. But then FAT standards evolved, like ISO standards. 19150 is the most known out there. And something followed the next decade, which I call the dark ages. So always about ownership and compliance. There were also catalogs like GeoNetwork who tried to tackle all these complexities. But most of the time, as a software developer, it was about standard compliance, checking all these very complicated standards and over-engineered standards. So it wasn't really fun back then. And 2013, we decided to re-engineer all that. We said, stop, we can't use that anymore. We re-engineer all that. We created our own data catalog. We called it MetaCat. Funnily enough, I don't know if you know, Netflix also released the tool. It's called MetaCat. It was 5 years later, so we had the name before then. And we introduced features like lineage, quality, and a metadata first approach. So like in software development, test-driven development, we wanted you to firstly create metadata, and out of that metadata, create the assets in the systems. But 2 years later, LinkedIn published Warehouse, their own metadata solution as open source. And so we decided, okay, it doesn't really turn out for us to keep on working on MetaCat. We adopt systems which are open source. Also, light metadata standards like STAC for Earth observation or NGSI for smart cities evolved, and they really helped us to integrate the things better. Yeah, and 2022, I get to know OpenMetadata version 1.0. I was evaluating a lot of other solutions back then, and yeah, it caught my attention, and there we are. So the main problem for me is all about data lifecycle management. So the data management and lineage, all these tools have features for keeping lineage and data management, but only in your gold standard data warehouse solution you have. So in your, don't know, Snowflake data warehouse, you can do all that. But as I said, our sources are external providers mostly, and the integration don't cover that. So we have here a great lack of capabilities to come here from our preservation layer back to the source actually, or even, as I said, metadata first, to the planning which data assets you need and you want to incorporate. And also down the stream, by sharing and then recycling your data assets, there's a huge lack of capabilities. So our goal is to cover the whole data lifecycle. Why did we choose OpenMetadata? First of all, for us it was important that the platform is coming with a comprehensive but flexible core metadata schema and a user-friendly UI. So we wanted to bring collaboration into the game. Yeah, and central features as column lineage and observability are must-have. So that's clear. And as I said, OpenMetadata was version 1.0, so it's rock solid and production ready and easy to deploy at our customers, which mostly use on-prem systems still. Also, the extensibility that we can do custom connectors and can have a well-designed API, which we rely on. Also the Airflow-based backend. And what I really like is this quite new feature of plugin apps into the UI. I'm really curious how this will turn out in the long end. So there are a lot of use cases I can think of how to extend the UI. Last but not least, no one can handle data governance alone. Collaboration is key, and OpenMetadata helps us to collaborate over our data assets through its features, but also because of this active community right here, where we can exchange how things are done the best way possible. Our solution, the Spatial Connector, especially, plugs into the ingestion framework. It relies on the field data abstraction library, and so it's able to integrate about 300 spatial formats at once. So you can Google GDAL. They have a listing of all the formats it can use. Not only geographic formats or spatial formats, also just an Oracle database or anything you can imagine. What we are still working right now are raster formats like cloud optimized GeoTIFF and NetCDF. And you can also access this data directly, not only on your local file system, but also on any web-based resource like S3 or HTTP. Really doesn't matter. We also worked quite hard on the spatial pipelines. So there are ETL tools and pipelines in the spatial world too. They're quite special. So there are tools like the feature manipulation engine, which is basically an ETL tool we want to incorporate. And these tools don't have a server or an API, so we have to push metadata into the system, and therefore we will use the API. And also we want to connect to our smart city systems like FiWare, msGIS standards, where there will also be a connector soon. What's the key benefits of all of this? Yes, the holistic data lifecycle management, as I call it. You will be able to cover all your data during its complete lifecycle. So not only in your system, but the lineage back to the data provider where you collected your data, or the sensor, or anything where it comes from, and you can clearly say the data about the data quality. Is it up to date or not? Data owners are also able to collaborate on their very own format-specific assets. So let's say if you collect data from NASA, like satellite imagery, they won't collaborate with you in your system, in your data warehouse. They have their own metadata standards, they have their own systems, and so you don't need any proxy assets. You can directly incorporate the metadata into your system. And last but not least, your consumers get a real one-stop shop solution for really every data. Doesn't matter if it's spatial or not, and its lineage, and yeah. So you can find all that on our GitHub repository. It's published, and we are open for any issues and requests. But also I have to admit, our main focus is to get first drafts of all the other building blocks I just explained to you. So we want to keep on with the spatial pipelines and the smart city connector, and then iterate and improve on that actually. And also we support you if you would like to contribute. So just feel free to contact us for sure. Yeah. Okay, and I would also like to close my presentation with the phrase, good things come to those who wait. So I have to thank especially Colette for their efforts to build up this great community. And I think there might be some questions we could answer now.
Awesome. Thanks a lot, Jürgen, for the presentation. Also love that you have everything in GitHub. So if anyone else is in this GIS space, you need to also bring all this metadata into your instances. Make sure that you are taking a look into that. If they are able to solve this big complex use case, I'm sure that there's something that all of us can learn and can reuse from this implementation. So thanks a lot. It's great to see how we are getting all of these different implementations. And I think that it really resonated, one of the sentences that you said, right? That is regardless of the origin of the data, right? It can be random NASA satellites, it can be our own maps, it can be the weirdest format that you can imagine. You use the framework, you use the APIs, you bring everything into central place, and then from that moment onwards, you can enjoy all the benefits of having all the metadata integrated. So I think that you are really, let's say, taking all of the benefits of this API first architecture, this standard language that we're building here. So it's really, really awesome to see all of these different use cases coming into life. And thanks again for sharing. If anyone has any question, let's use the chat. We'll keep also some minutes in the end, and we'll also make sure that we are sharing these slides so that you can directly contact Jürgen. You can also collaborate with the special custom connector, and we can take it from here. And thanks again, Jürgen, for your showcase on how you're bringing this GIS data or metadata into life on top of open metadata. It's awesome to see all of these different use cases. If anyone else here would also like to present how they are enjoying the open metadata product, please get in touch with us. We can schedule a slot for an upcoming meeting. And thanks a lot for being here. Thanks a lot for your attention, and looking forward to meet you in our next community meeting. Enjoy the rest of your days.